My name is Michelle Titolo, as Louis said. I'm a lead software engineer here at Capital One. And today I'm going to be talking about lldb. So hopefully everyone here in the room knows what lldb is. It's our wonderful, amazing, and oh so useful debugger that we use to debug our iOS apps, our macOS apps, basically any code that you can write in Objective-C or Swift or C or C++, which people forget, but lldb also works with them. So what are we going to cover today? First, lldb basics. While there will be a lot of advanced information in this talk, I always start out with like brief introduction for people that might not be as familiar with lldb, just so that we can all get to the really cool advanced stuff together and have a basic understanding. Next, we're going to be doing advanced debugging with thread, breakpoint, and watchpoint. And lastly, but certainly not least, is the script command. So let's start out with some of our lldb commands. First thing to know, and many of you who work in mixed apps know this, whenever you've paused your application, wherever you paused it, that is the language you are going to be working in. So if you paused in an Objective-C function, Objective-C method, lldb is going to start talking in Objective-C. If you pause in a Swift function, lldb is going to be talking in Swift. And this, we'll come back to this later, but as we're going through all of the examples, I just want you to keep this in mind because now that Swift has become really prominent within the iOS development community, we have to start worrying about, oh, how am I going to debug this if I'm doing bridging between two different languages, especially when you have like ping-pongs back and forth between Objective-C and Swift, it can get a little complicated. And as I just said, Swift is really, really super popular. Unfortunately, the feature set in Swift is not quite as robust as Objective-C. So unless I call something out, assume it's the same for both languages, but I will also make sure to call out the differences when they do happen, because it's kind of like you learn lldb once, and then you kind of have to learn it for the other language that you might not be using every day. Okay, so lldb command basics. PO, everyone loves PO, printout, right? Sounds great. How many of you were developing apps when Apple was using GCC, before LLVM? Actually, that's a good number of hands in here. So many of you are familiar with PO, but this actually isn't an lldb command. This is an alias that they created when they switched from the GCC compiler and GDB debugger so that people who were already working with GDB could just do the same things. So this maps to this lldb command, which is much more difficult to remember. You'll still probably be wanting to use PO. It's totally fine. But you'll see where this comes in a bit later. So PO expr -o --. Don't know what the -- means. This is just for printing out things. You're pretty basic. This is kind of the part where everyone starts using lldb. In Swift, it also works the exact same way. And in Objective-C and Swift, you can also call functions and get the results in your console. If you want it to be a lot prettier than those pointer values that we just saw, you implement the description method. Anything that inherits from NSObject already has this. In Swift, you can also just implement a description method. And this will print out something a little bit nicer to read rather than a pointer value, because pointer values aren't really that useful. P, which is PO's slightly shorter cousin, works in a slightly different way. So again, this is another holdover from GDB. It used to be just print, but in our world, it's actually maps to expression --. No options, just the --. And so when you're in Objective-C, this will also print out type information for you. So you can not only see what the value of something is, but also what type it is. But the powerful part about P is when you're in Objective-C, you get to dereference your pointers. So if I wanted to inspect what this car variable is, it'll print out all of the ivars, which can be really useful. And you can also get this in Xcode's little side panel that shows you all this stuff, but sometimes it's nice to have it in your console. Swift, same thing, PO works. But Swift pointers, you can't dereference them. It doesn't work like that. So if you try and do the p star, won't work in Swift, unfortunately. But don't worry, there's a way you can get that same kind of information in Swift, which I'll tell about in a little bit. The biggest powerhouse feature of expression is, unlike the commands you had in GDB, you can use the expression command to modify values at runtime. So if you have a situation where you're debugging a really hard to reproduce case, and you're just like, I just want this variable to be this value, you can use the actual expression command. So in this case, my code has a bug where if the year is 2013, something weird happens. So I can run a really short command, expression self my car year equals 2013. And then the next time I print it out, you have 2013. So you can just kind of modify whatever you want at runtime. And this works with Swift as well. Next basic command is called frame variable. lldb has these nice shorthands. So frame variable becomes frv. It's just less characters to type. And lldb in Xcode 9 does have autocomplete now. So this is a lot easier to type out. Yeah, it's really sweet. So frame variable, so wherever you've paused your program, it will just print out all of the current variables in scope. Again, you can see this in Xcode's UI, but sometimes you want to get it out in your console. Now remember how I said the p star doesn't work in Swift, but you can pass in the -F option and your object, and it will basically do the exact same thing, except a little bit more in depth. So if you're using Objective-C, you want to get full object information, do the p star. In Swift, it's frv-f. And yes, don't worry, these slides will be available online. There's a lot of commands that I'm throwing at you, so I hope you've all had your coffee or chamomile tea. Okay, next one, BT, which actually corresponds to thread backtrace. This is, again, one of the useful ones that people usually start out using. Wherever you've paused your program, this will just print out what happened beforehand. If you've seen the Xcode thread menu on the left-hand pane, this is exactly the same information. You're just able to access it programmatically. Okay, and now going around. So you have your program paused, because lldb is really powerful when you can pause stuff and play around in it. How do you get around? The next few sets of commands also have really, really teeny tiny little buttons in Xcode that if you really want to tap, you can. But whenever I'm debugging, I find it more useful to just hit a key rather than move my mouse, find the correct teeny tiny little button, and then hit it. So the step command, all it does is it goes into a function. So in this instance, the breakpoint is on an allocator, and when you step into an allocator, it goes to where property is declared. Pretty simple. Next is one of the ones that you'll probably use a lot, and all it does is goes to the next line without going into any functions. Thread, step out, or finish does the opposite of the step or step in. So for instance, if we're in a honk function, I step out or thread finish. I go back to where that method was called. So you're able to go in and out of the different call stacks that you're dealing with. And then last but not least is our lovely friend continue, which unpauses your program and lets it keep going. So you hit C. This is the one that I use the most because, as I said, the Xcode buttons are really tiny, and I have a 27-inch screen. So C is like my best friend. You just C, and it just continues. One of the little known facts about lldb is that in your home directory, you can create this lldb init file, and it works a lot like a git config. So if you find yourself doing the same commands over and over and over again, and you don't like typing out some really verbose things, you can create command aliases. So this will automatically load when lldb starts up in your Xcode, or if you're using lldb independently. This is well documented online. As we all know, lldb is open source. So you can go through, create as many aliases as you want, and yes, Xcode 9 will autocomplete them for you. It's like my favorite new feature in Xcode 9. Okay, process. So obviously, apps have a lot of processes. But what people don't realize is that lldb is super flexible. So if you have a running simulator instance, and you're like, oh, it would be really great if I had a debugger on this in the state that my app is in right now. Well, guess what? You can do that. You can run lldb in a terminal, and you can just run the process attach command, give it whatever the process name is, and it just attaches. And then you have, obviously not the nice, pretty Xcode UI, but since you're learning all about lldb commands, you can go through, start setting breakpoints, start inspecting frames, playing around with things, just as you would normally. So I've used this a couple times when my simulator's gotten into a really weird state, and I'm like, oh, I'm not a debugger. It can be really useful and powerful. Okay, and then sometimes you get a little stuck, right? We've all had this happen. You're like, you accidentally entered some key commands, you have no idea what's going on, and you're just like, I need some help. So lldb has a lovely help command, right? It'll tell you all of the information about a different command, but if you're used to using some other command line tools, the way that you specify what you want information about is a little weird. At least I found it was, coming from especially like Ruby-based packages. So if you want help on the breakpoint command, you write help breakpoint. But let's say you want information on like there's a command called command, and I want help breakpoint command help. Well, you just put help breakpoint command, and then if I want the add information, so like if you're gonna write any command in lldb, just prefix that with help, and it'll print out the help information for you. And as I said, don't try and use the dashes or the dash help. None of this won't work. It'll just complain at you, which is really sad because that's how a lot of things work, but unfortunately, not lldb. Okay, so now those were the kind of really, really basics, the stuff that if you've been using lldb kind of on the surface, you've probably heard all that before. But now we're gonna start getting into some of the more advanced features, and we'll get to see some really, really, really cool stuff. So, thread. We all love our threads. We need them. You can get information about your threads. Pretty simple. Thread info. Again, this is shown in Xcode in a panel that you have to remember how to get to. I like using the lldb commands. And it will also give you the pause location, what function you're in, what file you're in, what line number you're on, what queue you're on, a whole bunch of really useful information for debugging. Thread list, lists out all your threads. Again, Xcode shows this for you, but I like having it in the console sometimes so that I can just focus on one place where I'm doing my debugging. One thing that Xcode cannot do for you is continue a thread up until a certain point. So let's say you have a function that's like 100 lines long. I hope you don't, but in case you do, you can run the thread until and give it a line number, and the thread will continue until it hits that line and then pause again. So if you are at like the beginning of a function, inspecting, playing around a little bit, you're like, okay, now I want to see what happens 40 lines down, you can do that with this command. It just does that, it continues, and then it pauses again, and then you can go around, play around with whatever you want. Again, not a UI feature in Xcode. You can also return early from a thread. So if you're debugging something and you have a method call and you're like, well, I only care that this method returns a certain value, as long as you're in that method, you can run thread return and then something, and it'll just return it for you. So you can actually skip over the execution of your method if you already know what state you're looking for. So you can do like thread return null, thread return and its number with int, thread return string. All of this is Objective-C. Unfortunately, the support in Swift is not quite there yet. So if you try and do like thread return true, you only support setting simple integer and float return types at the present. And this was done with Xcode 9, so file radar. There's a couple of things I'll be saying in this talk. That's file radar. So yeah, thread return in Objective-C, super fun, super powerful. Swift, you basically have integers and floats you can play with. Okay, everyone's favorite topic is breakpoints. It's kind of like the most powerful thing that we all use day to day in working with our code. And this is probably something you also already know about, at least on the surface, but I'm gonna go into some really, really fun advanced details on how breakpoints can become even more powerful than you already think they are. So if you've never heard of a breakpoint before, you basically let your code go for a while and then it stops. Just like MC Hammer. So if you want to list out your breakpoints, again, Xcode has UI for this. The Xcode UI will not show you any breakpoints you've created programmatically, though. Breakpoint list will show you the breakpoints created both in Xcode and via the commands in lldb. So if you start actually using the lldb commands to do stuff, you want to use the breakpoint list command. Again, lovely shorthand, br list. Breakpoint is pretty much just shortened to br, so anything you do with breakpoint, you can do with br. So this will list out, so this program that I had 2 different breakpoints. It lists out the files, line numbers, methods, all of the basic information that you would need to know about where your breakpoints are. And of course, you can set breakpoints, modify breakpoints, delete breakpoints. Kind of basic things. Again, Xcode has UI for doing some of the things you can do with these commands. And I know we all just love plopping a breakpoint in on the side. But I'm going to show you some really cool stuff that you're not going to be able to do. But first, you want to set a breakpoint. You can pass in a file and a line number, and it will set a breakpoint for you. You can also set what Xcode calls a symbolic breakpoint. So you can set a breakpoint on a function or a method call. So in this case, I'm setting it on the car change gear to method in Objective-C. And then it just sets it. In Swift, you can also set those breakpoints, but the function signature is a little funky, so I'm just going to explain what it looks like, what it is really quick. So whenever you're dealing with a function signature in lldb with Swift, it's always going to be super verbose and long. This is because Swift has modules. So you start out by having everything's module name spaced. So you start with your module name, your type, then you have your function signature as you would have it normally with all of the types and parentheses. And then any type that you have within the function signature also needs to be namespaced. Swift is really, really into namespacing, in case you hadn't already noticed. So it's a little verbose, but the nice thing is if you don't want to figure this out on your own, if you set a breakpoint at the line that is inside this function, it will print it out for you so you can just copy and paste it. That's actually how I got this. And then if you have something that is a built-in Swift type, like integer or string, you are using the Swift module name instead of like your app module name. So that is functions in lldb with Swift. It's really verbose, but you'll get the hang of it. OK, some of you probably saw the breakpoint shrink down to br and be like, oh, what if I create an lldb init command alias so that it's just b? Well, b is actually already a thing, and it's an even shorter shortcut to what br already does. You can't do everything with b. You can do stuff with b that you can't do with br. So if you want to have a really shorthand way of setting a breakpoint in a file at a line, you can do b, file name, line number. And it just works. If you try to do this with br, it won't work. It doesn't understand it. So if you want a super, super, super short way of typing things, just use b, file name, and line number. OK, now we're going to get into modifying. Xcode in, I think it was like Xcode 6, created the first little tooltip popover for breakpoints where you can actually set like breakpoint conditions and have breakpoints start doing really interesting things in the UI. But this has been a feature of lldb for many, many years. So in this case, we're going to modify this breakpoint to only stop when the speed of the car is 15. You do that, it resumes, Xcode will break, and then that's it. The modify -c adds the condition. You can obviously do any sort of compound stuff that you want. So you have speed equals 15 and gear is 4. And this is an Objective-C enum, because Objective-C enums are integers. lldb only understands the integers. Fun fact. But yeah, you can do any sort of thing inside that quote as long as it would be a single line of execution within your program. Thankfully, in Swift, enums are first-class citizens, so we just get to use our nice named enum types just like you would anywhere else in your Swift code. You can also do function calls in these, just normally, pretty simple. And then something that Xcode also has for you is this thing called ignore count. It's the -i flag. And just one note on this, and you found this behavior in Xcode too, because all of the Xcode UI that is surfaced with debugging relies on these lldb features. So anything that you can do in Xcode, you can do with raw lldb commands. So this -i thing is a little weird, and if you've used the hit count in Xcode, you've probably noticed this. The documentation says this is the thing to set the number of times this breakpoint is skipped before stopping. But what this actually means is that it is the minimum number of times. So if you set I to 17, the breakpoint's going to stop at the 17th hit, the 18th hit, the 19th hit, the 20th hit. And the only way to unset that is to restart your program or delete the breakpoint. You can't just enable and disable the breakpoint to reset that counter, unfortunately. So use I with caution, and only really use it in places where you're OK with it then continuing to get hit over and over again. And last but not least, you can delete breakpoints. Oh, and in case you didn't notice, every breakpoint has an identifier number. So 1, 2, 3, 4, 5, 6, 7, that's what the 2s are, the 1s are. I just realized I didn't have a slide on that. Darn. But yeah, so breakpoints are always referenced to by number. And so you can delete number 2. Pretty simple. You can also enable disable breakpoints in lldb, just like you can in Xcode. And these are also just pretty simple. Output is not really that special, but just showing you what it all looks like. Every time you deal with a breakpoint, it'll always print out more information about the breakpoint than just the number, because developers realize that you're not going to remember where breakpoint number 3 is, but they know that you will remember that I have a breakpoint in like viewcontroller.m somewhere, and they'll help you out with that. Okay, now we're getting into the fun stuff. So again, Xcode added a smaller subset of this feature a couple of years ago, where when a breakpoint hits, you can actually do something. So like, you can have something be done automatically for you, and that's what breakpoint command is. For instance, if you wanted to run frame variable when your breakpoint stops, you can do breakpoint command add. The -o is for basically a one-liner. There's only going to be one thing, no multiple lines. You're just running one single command, breakpoint number. And then when that breakpoint gets hit, it's going to run whatever command you just passed in. Xcode has this one feature where it can do the one lines just fine. But one thing you can do with actual lldb commands is you can have multi-line commands. So for instance, if I wanted to not only do frame variable, but I also wanted to continue, like I didn't actually want the breakpoint to pause the program, you can type that in. And you can type in any other lldb command. You can have it print the backtrace, you can have it print the thread information, you can have it do anything else that you can do in lldb in these commands. And then as it executes, it'll hit the breakpoint, run your commands, and then continue on, and that's great. And because you can add commands, there has to be a way to list them, of course. You can also delete them, pretty simple. One thing to note, whenever you're adding, modifying breakpoints in lldb, they do not persist between runs of your application. So if you're used to using the nice, pretty breakpoint UI in Xcode, those breakpoints stay around. So in the first iteration, breakpoint's still there, you rerun your app, they're all there. These, unfortunately, do not stick around. So if you're starting to do anything really advanced, I suggest having like a scratchpad editor nearby so that you can actually copy and paste stuff in and out. It's a little annoying, but we deal. So, Watchpoints. This is something that's not in Xcode, which is why I always love telling people about it, because this is the stuff that like kind of blows people's mind. Watchpoints are exactly what you think they are. You're watching things. So a watchpoint tracks a value over time, kind of like KVO. So how many people have ever been in that situation where there's some variable being set to some random value and you're like, I have no idea where this is happening. Like, what the heck is going on? Yeah, like it's something that happens all the time. So then you're like, okay, well, I can do KVO on it, so I have to add like a function to add observer, and then I have to implement the KVO observe value for key path method, and then you're like, oh, but I only want to know if it's going over 1,000 because carts don't really go that fast. Or you like override a setter, which is also how you usually do stuff like this in Swift. You override setter. You're still like, I have no idea what's going on. Well, If you think of a breakpoint as pausing the execution of your program in a specific place, a watchpoint is pausing your program at a specific value of an object. What does this mean? So you want to set a watch point. Again, watch set, watch point, watch, a little bit easier to type. So in this case, I want to check out my speed because for some reason it's going 1,000 miles an hour, which is really, really fast. And this is all Objective-C, so you're going to be like, I want to watch my speed, self-speed, nope. Self-arrow speed, nope. IVARs, yeah. IVARs are the way to go. It's not going backwards. There we go. Underscores, so you want your IVARs when you're dealing with Objective-C. Thankfully in Swift, they made the same choice, so you can just use your properties and you can use self, you can not use self, whatever. This totally works. And then that's it. So you will now have a watch point which will pause the execution of your app anytime the value of this speed changes. Pretty cool, right? But it gets cooler because just like breakpoints, you can modify them to have conditions as well as ignore counts. So you can have conditions set, so watching my speed. I want to only know when my speed reaches 15. You can do that, and it'll only fire that watch point when your speed is at 15. And then the same thing happens with ignore count. You can ignore the first 17 times that this variable is changed, and then 17th time it'll pause. In Objective-C, it gives you this nice little old value, new value. Swift doesn't unfortunately have those last 3 lines, which is kind of sad. But when it comes to Swift, again, we have a little stuff that's different. So in Swift, you can, again, set your watch point, and you're like, hey, I want to check when my speed is 15. And then it doesn't work. So unfortunately, the watch point conditions don't work in Swift right now. And as I said, this was Xcode 9, so it'll be like this for probably at least another year. File a radar, please. I can send you code if you really want to. Because this would be really super fun. I've used it a lot in Objective-C, and it's really helpful. And again, just like breakpoints, you can add your lovely commands. So in this case, I'm just going to print out the speed and continue, and then prints it out and continues. So for the most part, for actually basically everything, whatever you can do with a breakpoint, you can do with a watch point. So you have delete, enable, disable, all that stuff. Pretty simple, basic. OK, are you ready for the really, really fun stuff? This is the part of the talk I love the most. Feeling a little overwhelmed? Too much information? We're good? We're good? OK, see some thumbs up. So, script. And you're probably all wondering, why do I have this really pretty scripted word of script? So script is both an lldb command and an option that can be passed in to any time you're working with like breakpoint commands and watchpoint commands. And so I hope you're all ready, because we're about to start looking at Python. Yeah? Yeah? One clap. You're probably like, what? This is iOSDevCampDC. Why am I talking about Python? So script lets you write code to debug your code in Python. Python and lldb work really, really well together. And this can be like one of the most powerful things that you'll see, especially if you have some really, really strange race conditions, if you have situations that are really hard to debug. And don't worry, I'm going to give you all the details and show you a really, really useful example. But before we get started, you're like, yeah, this sounds really cool. You have to copy and paste everything. Yeah. There's no way to, just like you can't save your breakpoint information anytime you're working with the Python stuff, you also can't save it anywhere. So again, have a scratchpad editor nearby so you can copy and paste your stuff. Also, for those that don't know, Python is space delineated. So spaces matter, line breaks matter. So you'll want an editor around so you can fix those issues as they come up. Because lldb will just kind of fall over if you have your spaces wrong, which makes me kind of a sad panda. But don't worry, script is really, really, really cool. OK, so the script command, if you just run it in lldb, any lldb doesn't actually need to be attached to anything. You can just open your terminal, and if you find where the lldb binary is, you can just run an lldb shell and just play around in it. So script, help script, this is what it says. You pass an expression to the script interpreter for evaluation and return the results. You drop into the interactive interpreter if no expression is given. AKA, that means if you just pass in script, you'll be interactive mode. If you put script and then some other stuff, it'll do the other stuff. So what does this actually look like? So as I said, you type in script. Hey, look, you're in the Python interactive interpreter. This is a just plain like Python shell. So you have all of your standard Python libraries. No, you cannot import things. Unfortunately, I couldn't figure out how to get that to work. But the most fun thing is that there's already this variable populated for you called lldb. And so, for instance, I'm going to print out what the lldb debugger looks like. Oh, hey, there's a debugger instance. It's got an ID. I can look at my lldb target. I can look at my lldb process, see where it is, what's happening. I can look at the thread that lldb is stopped on. But then I can also check the frame that it's currently stopped on, which then prints out, hey, look, I'm in my cars project, and I'm stopped in viewed load. So this lldb variable gives you access to do all the other commands we just talked about by using lldb in like itself. So all of that is available to you in Python using this way. So, and then of course, always quit. You'll mess yourself up if you don't quit, because you'll just start to like typing C, and then Python will be like, I don't know what C is, so always make sure to quit. So the power of scripts is when you get to write functions. And this is the how to write code to debug your code. If you're writing functions, there's a certain format that has to be followed. Don't worry, I'm getting to an example, but in order for you to understand the example, I have to go through all of this so that you're not like deer in the headlights, because it kind of gets a little crazy sometimes. So if you want a function, for instance, to fire when a breakpoint is hit, you name it. It always takes 3 variables. Like lldb is really, really strict. If you don't have 3, it will fall over. So the first one is the current stack frame for you to use. Then you get your breakpoint location, so you can find out what file, what line number, thread, all that stuff. And then there's this random one at the end that you have to have there, which is called the Python section dict, but it's actually just useless, but you have to have it anyway. Yeah, they really like those unused last variables. It's like, we reserve the right to have another variable at some point. You're not going to really care now. So that is what it looks like, and now we're going to go into a sample case. I generally don't really like having a lot of code on my slides, but in this case, I really wanted to highlight how powerful this can be, especially when you have some really nasty and hard to debug scenarios. So I want to create a function that will break the program when at a specific point when the change gear to function is in the call stack. Now, if you were trying to do something like this manually, you'd probably just set a breakpoint, and then every time the breakpoint gets hit, you'll look previous in the stack, be like, nope, the function's not there. Nope, the function's not there. Nope, the function's not there. And I actually came up with this function while I was debugging a cell reuse issue with really fast scrolling, which is like ridiculous if you're trying to figure out when something is in the call stack, because there's just so many function calls that it takes forever. So, warning, a lot of code. I'm going to go through it line by line. Don't worry, and of course slides will be up, so don't worry about it. So first thing we're doing is we're figuring out what stack symbol we're looking for. I have the change gear to, just like I would have it if I were debugging with a breakpoint, same symbol. I have the name of my function and the declaration with the 3 variables, including the useless one. You have to do some weird things with globals. This is all documented online. It's a little weird. Python's a little weird to me, so first I'm grabbing all of the functions in the stack. That's what you can do with that frame variable. You can get all sorts of crazy stuff. Then I'm basically taking 2 arrays, finding the intersection, which is seeing if that function is in the stack. If it isn't, continue. So returning false from one of these functions is don't stop. Returning true is please stop. And then obviously you quit. So it's only a couple lines of code, but this, I came to this after probably 2 days of debugging, and this helped me find my problem in less than an hour. So it can be really powerful. For Swift, you have to deal with your module names for any of your function names, just like we had to normally in other areas. But yes, this does work with Swift. And how you do this, so you have your function in your editor, lines are good, spacing's good. You then run breakpoint command add -s Python, and then your breakpoint number, right? And then it looks really super messy. But then you're done, and you exit out, and Xcode runs, and it breaks when the right thing is in the call stack. If you were going to debug something like this, it would take you a really, really long time. And unfortunately, these don't stick around, so make sure you have the functions elsewhere. You can also add single-line Python functions. So this one's just printing 1 + 1, which is 2 every time, but it's basically the same anywhere else. You just need to pass in the -s Python. OK, almost done. Because there's one more thing you can do with scripts, and this is with type summary, and this is using a Python function to better describe classes. This is if you don't want to implement description, or if you can't. So if you're working with a third-party library, you can't just like subclass and add a description method. You can use this. Unfortunately, it doesn't work in Swift. This is Objective-C only. Again, file a radar. Maybe a Jira ticket. I don't know where to actually file bugs these days sometimes. And this is the last one. Again, a little bit of code, but again, pretty simple. You have your function declaration, you get a value, which is the object. There are some special methods you can call: get child member with name, some ivars, get some other summaries because apparently they return objects. You return a string, which is what's going to be displayed. Now when you run type summary with this, you get this nice little description object that you can change at runtime without having to start and stop your code. So if you're working in Objective-C and you're trying to figure out what the heck's going on, you can just add this, you can modify it at runtime. And in case you were wondering what other use cases there are for script, because I'm a big script fan, I think everyone should know how to use it because it is a really, really powerful tool. Some things that I've done with it and heard other people do with it is conditionally enable breakpoints after other breakpoints have been hit. You can do that. All of lldb is available to you in the Python. You can check multiple threads for a symbol, whereas if you're just doing the really like symbolic breakpoint, sometimes you want to check all of the different threads, help with your asynchronous code debugging, and data formatters for everything in Objective-C. And also, you can actually write your own custom lldb commands if you really, really want to go in hard mode. So if there's an lldb thing you want to do that is not built in, you can actually do that with Python. So Python, in this case, really good. And that's all that I have for you. Thank you very much.